Thank you everybody for your time and attention. So this is actually a third session of our series. There are 4 parts in this series. And here are the co-presenters, Mr. Ram Bhaskar, myself, and Mr. Vijay Kumar. And this whole initiative of webinar series is to make ourselves stronger by learning together and thriving during these crises. And that's the same quote. We will always have to think from one level above than uh, the level where the problem has been created. So this is session 3, 21st of October, and we're gonna do a recap of the stuff, whatever has been presented in the last 2 sessions. And then session 3, we would be focusing today on 3 major topics. One is ESPIR, Electronic Spare Parts Interchangeability Record. Service management, when we talk about service management, very specific to the plant maintenance as well as the asset management service, and then fixed asset register or financial asset register. So which is also becoming more and more popular. If somebody is talking, can you please mute yourself? Okay. And then we will have a couple of customer success stories. Q&A as usual. For last 5 to 10 minutes, we will reserve it for the Q&A. The entire recap now. Session 2, what we have looked at, we had a recap of session 1, which was on the fundamentals of the core asset lifecycle management. That was the session 1. And in session 2, we have covered discovery and diagnostics. This is absolutely important. Without doing a discovery of the data as well as the processes, as well as the diagnostic of that particular data and processes, we will not be able to move forward with any roadmap, because without the fact finding, we cannot prescribe what needs to be done. And when we do the discovery and diagnostic, it is current data, metadata, analytical processes. So we do the discovery as well as the diagnostic of that. And then once that is done, as part of that, we look at equipment criticality rating, maintenance maturity assessment, and process maturity assessment and data maturity assessment. So that's what we have learned last week. And then what kind of influence the data and analytics can have on the process control, that also we have looked at it. And apart from that, we looked at the core data objects of the enterprise asset management, such as the asset or the equipment master. How do you manage it? What kind of assets you have, and function locations, how exactly the functional locations are organized, and then document indexing and linkage of that, because without the index and Henny, can you please mute Reinhardt and also pass on a message, please?
I have muted him, but he keep on coming back on, so I will talk to him.
So kindly move him as a normal participant, probably. Thank you. Sorry for the interruption. So the core data processes, equipment master, function locations, and document indexing and linkage, and then the bill of materials. And when we talk about bill of materials, there are a lot of bill of materials, but that are essential for the asset management is equipment BOM, functional BOM. However, MBOMs, which is the material BOM, which is part of actually the materials management, but since we are covering all the BOMs, we have included even the material BOM as part of the asset management. And then maintenance items, maintenance plans, and frequency of that, and task list, which is the equipment task list, function location, and generic task list as well, along with some of the instructions. And then measuring points and counters. We might repeat the measuring points and counters because we did not add enough time last week. And then we had the Q&A. So that was the recap from the previous session. Now, how can you actively engage? This is just a repetition of it. There are panelists. You can ask them questions, type them, and there would be a quick poll as well post this session. And then if you would like to get in connect with us, it's webinars@pilogroup.com. And then there is also a ESPIR flyer under the handout session that you can download it for your reference as well as further pursuit. And then if you would like this webinar to be repeated, or you would like to have the link of this to play it back at your own convenience, please do contact us. And again, we are emphasizing that if anybody would like to embark on the journey of it, they will have to start with discovery and diagnostic process, because that will establish the way forward as well as the roadmap, which would result in quick wins for everybody. And then there are a couple of reports that can be downloaded from our latest website, pilogroup.com. Now, diving into session 3. First of all, use case of ESPIR management. Many people might have heard about it, but most of them might not have heard about it. ESPIR, what exactly is the ESPIR? Let's look at what are the real-time scenarios where this ESPIR would be used. When we look at the entire ESPIR, which stands for Electronic Spare Parts Interchangeability Record, it's a long form, so that's why we are referring it as a ESPRYE, because it's an electronic version of it. Prior to the electronic version, there used to be only the the hard copies of it printed out on A3 or A2 size papers. But since this is an electronic, and we also would like to acquire the data electronically, we also would like to capture the data electronically into the system. That's why the name and the module that is part of our governance solution is ESPIR management. What are the real-time scenarios? These are the real-time scenarios. Some of them are mutually inclusive, some of them are mutually exclusive. So greenfield projects, when we talk about greenfield projects, there's nothing, no infrastructure, no plant, no production unit is there. It's a greenfield project. At that point in time as well, ESPIR will make huge difference into the lives of the operational teams going forward. And then brownfield project, wherein already there is some infrastructure available, but you would like to build a new unit, or you would like to have some expansion done. So those are the two cases wherein ESPIR would be used, and it will be absolutely useful. It would be crucial for the projects. Engineering guys would love it, whereas the ERP operational guys, they might not know the significance of it. That's the reason we said that let's propagate the message how you can actually capitalize using the ESPIR within the projects, and be it greenfield project, be it brownfield project, it is absolute a necessity. Now, apart from that, people, they might not refer them as brownfield or greenfield, but people might also say that, oh, I would like to replicate the same production unit or same plant in another location. Yes, absolutely, ESPIR would make sense there. Now, I would like to upgrade my production unit, okay, with the latest information, latest technology or improved processes. Yes, that's also is required. Or a technology change, majority of the plants are undergoing a technology change at this point in time. So, during the technology change as well, ESPIR would make absolute sense. It has enormous value, rendered into those kind of projects. Or we have also seen that many plants, they switch from one OEM to the other OEM when it comes to those equipments, and those equipments they would like to upgrade to the new OEM because of it could be again a process requirement, process change, or a production change, or product change, whatever it could be. So in that cases as well, ESPIR would make absolute sense. And then last but not the least, which was evident from even the previous scenarios as well, that expansion of production capacity, whenever somebody would like to expand that, and then which means that you will have to increase the number of equipments, you would have to increase the facility. In that case as well, the ESPIR would be used. Apart from this, there are other cases as well, but we have listed down the majority of the use cases or the applications. And what are the objectives? Why exactly the ESPIR is used? To establish right master data for any ERP system or CMMS system or any operational system. So that's the first objective, to establish it when you are building the plant or before you start building the plant, the data is available. And how is it available? We'll go deep dive into that and we'll go through that. So it is to establish the right master data for ERPs or CMMS or operational systems. And then the second thing is that to optimize the inventory, probably it might be a brownfield and you might have already the production unit. You might have exactly the same unit, but you are now extending your facility, you are expanding your facility, you are doing a capital expansion of that particular business unit or plant. In that case, you have already those equipments, you have already the linked space, but you want to optimize it. You do not want to over procure, you do not want to have surplus stock. So in that case as well, the ESPIR would give a lot of benefits, and that would also be the objective. And then establish asset management practices. When we talk about asset management practices, session 2 was completely filled with all the objects such as the function location, equipment master, and then equipment bomb, task list. All of that you can really build out of this ESPIR. And then establish sourcing. This is also important. Many a times the EPCs, who are the engineering procurement contractors, the guys who are building the plant, those guys, they actually give everything away, and they, after 2 years of establishment, they walk away. Sometimes they might do the maintenance of it, sometimes they might even walk away the moment the production has started. But during the course of action, maybe next 2, 3, 4, 5 years, you might not face any problem. But after 2, 3 years, when the spares need to be replaced based upon the manufacturer recommendations, based upon the manufacturer manuals, at that point in time, you would like to source a spare, and you might not be able to source a spare if you do not manage if you have not managed it via the ESPIR, or if you have not captured the information of the sourcing. So again, it is very important to establish sourcing. ESPIR is used. And then minimize the downtime during operations. So if you have not onboarded all the data pertaining to the spares as well as its relevant equipment, then you might have longer shutdowns, longer downtime during the shutdown, or it could also be that longer downtime even during the operations as well, to minimize that, which is again to reduce the wrench time as well. That's also our wrench cost. That is also another terminology. And then reduce the project capital cost, and we can share with you numerous examples of it, because we have been performing the entire ESPIR management for greenfield, brownfield for the past 18 years or so. We have sophisticated tools, we have sophisticated methodology, processes that are embedded within our solutions, that can manage the entire expansion, which is brownfield or greenfield projects effectively. And we have saved millions. Now, what exactly is the ESPIR consist of? Let's deep dive into that. Now, before that, we need to understand where exactly the ESPIR coming in. What is it? Is it the entire plant data, or is it the data pertaining to only one particular package, or pertaining to only one particular equipment, or pertaining to one system or one function or one department? Let's look at that. So if, let's suppose, we have a business unit or a plant, which could also have multiple projects, but in this case, let's take 2 projects, and project 2, EPC 1 and EPC 2, which are the engineering procurement contractors, EPC 1 and 2. And for each EPC, you could have multiple vendors. It could be hundreds of vendors, or it could be few vendors, depending upon what kind of equipments those vendors are bringing in. And those vendors could also be the OEMs, or those vendors could also be the OCMs as well. And each vendor will be given a range of the SPIR, saying that these engineering packages you will have to supply along with the equipment that you are going to bring in, or any system. Maybe it could be a pumping system, or maybe it could be a condense system, maybe it could be a rotary system. So whatever it is, so it's everything is combined into an SPIR. So SPIR is at a vendor level or at an OEM level, or a manufacturer level. So you could have hundreds of SPIRs, and each SPIR could have, maybe 10 or 20 equipments and 10 to maybe thousands of spare parts, depending upon that particular package, depending upon that equipment's necessity. Okay, so that's the structure. But within the package, what exactly we have? And generally, it is referred as spare parts data package or engineering package, which is the SPDP. And it would have a transmitter stating that this particular package is from this vendor under this EPC, under that particular project for this plant, and it has so many SPIRs, one, two, or it could be just one SPIR, and then how many line items it has, and what is the contract PO number, blah blah blah. So that's a transmittal information. And then it would have one or more SPIR sheets, and it would have multiple supporting documents such as cross-sectional drawing, or such as any even P&ID drawing, such as the manufacturer or references or manufacturer manuals. So it would have a lot of engineering supporting documents. So that is in its entirety is referred as SPDP, spare parts data package, or in general engineering package. Now that we have established that each plant, if it goes for an expansion, it would have multiple SPIRs, and which are part of the SPDP, how we would utilize this information so that we can feed it into the operational systems. Let's look at that. Now, before that, if you look at the ESPIR template, and by the way, we have enhanced, extended the original SPIR that was introduced by several industry experts, industry leaders in the past few decades. We have extended so that we could capture more information, and so that we do not have to depend on that particular vendor or EPC post the commissioning of the entire plant. Now, if you look at this information, let's quickly have a overview of that. ESPIR, we have the equipment information, which is the equipment tag numbers, model numbers, serial numbers, and these equipment tag numbers are actually referred in P&ID diagrams, okay, piping and instrumentation diagrams. And then installed number of spares. So for each equipment, how many spares are installed? Here are the spares. So each spare, so this spare is installed in this equipment with how many quantities, because the quantities could vary. So, and then spare parts description, obviously, and SPIR number, because to control the entire transmittal, how many SPIRs we have received from each vendor under each EPC for that particular project. So the SPIR has got internal numbering and ranges of that. And then equipment and supplier, equipment supplier information, as well as manufacturer details. You would also see that information. So we are capturing a lot of information here. And then sourcing info and pricing info. If you look at the sourcing info, we have the equipment OEM part number. So in future, the spare part could be purchased using that, procured using that. And then we also have the shipment days, which means that in how many weeks we can expect this particular spare to arrive at that particular location. So along with the price. So this is important, and all this information we will compile it, we will enhance it, enrich it, and we actually push it into the ERP systems. Now let's look at this. So this is a general flow wherein a PO registration happens, which is the purchase order registration for that particular, and then SPIR registration. How do we collect it? The intention of this flow here is that our whole objective here is that whenever we are onboarding new spare parts, we have to make sure that we do not create multiple records or redundant records or duplicate records. If we have already a record and that particular spare is available, then we should look at optimizing the min max levels of that spare, and then enrichment of that and registering the entire vendors, equipment bomb, all of that information which has been captured out of the SPIR, that goes into the system, and then it goes into a data governance solution, and then it goes into any ERP system. And what exactly is the composition of that? It's a unique MRO material components and make model drawing specification reference and frequency of it, linked material components and quantities and values and sourcing information. And in fact, we capture much more than this as well. But for the sake of illustration, we have taken only few bullets there. Once you take that data, and the data would look like this, it's just a snapshot of it. It has all the characteristic information, it has all the short and long text and image also comes out of our governance solution, and then all the other information is available. So what we have seen from the previous slide, let me go back, that now once we have this information, parent equipment tag, model and serial number, what we are doing is it's the equipment register for us, and that's what we have seen in the previous session. That's the equipment register. And if we have the spares and equipments link, that's actually the BOM information, equipment bill of materials information. And if we have the quantities, that's actually the installed quantities information. And once we look at the the drawing and the other, this is all the catalog information that's available. And then drawing position number, and then the OEM part number, this would be the procurement information, sourcing information going forward. And then what exactly is the quantity that is already available. Based upon that, this is the optimized inventory information, and then the shipment information, and then the price of that. And going forward with that, there's a lot of other information that is also being captured out of this SPIR. So we are on the fly, we are actually building a lot of objects from the asset master. So now the intention here is that when we talk about the equipments, or when we talk about the assets, we also have to in conjunction talk about its relevance to the other modules, such as the cross function of assets in material, the cross function of assets in the sourcing, the cross function of assets into the inventory, the cross function into warehouse conditions, and a lot of other things. Because when we talk about a specific function here, we are not just talking specifically about that, we are talking about all the interdependencies around that. So when we look at the enterprise asset management, two objects or two functions, they interact with each other heavily. One is the material master, the other one is the plant maintenance. And by the way, in this example, we are showing the SAP specific example. But it's same for any other system, be it for Oracle, Maxima, or any other stuff. But the example that we are illustrating here is the SAP specific one. Now, if we look at the material master data governance, so when we are trying to register a spare part, we should also make sure that what is the parent equipment, where exactly it is used. If it is general, then that's a different case. You can link it with multiple equipments, but if it is a specific, we need to capture that. So any governance, any data governance around the material master must also extend an arm into plant maintenance. If we are not doing that, then we are losing the cross-function dependency. We are losing actually the entire value chain. That is the proposition that we are bringing to the table. And then when we talk about it, it must be a real-time integration with the ERP systems. The reason for that is that if you do not have the real-time integration, you won't be able to check for the redundancies. You won't be able to check for the anomalies. You won't be able to check for the ambiguity between the systems. So that's why the governance solutions need to always work hand in hand with the operational systems. And that's the cross-functional integration. That's what we are talking about. And between the governance solution to the SAPs or any ERP systems, it must be a real-time synchronization. And then, from the plant maintenance perspective, if somebody is creating an enterprise asset management object, such as a functional location or an equipment, or it could be, the EBOM, whatever it is, also dependent on the material master stuff, such as if you would like to onboard an equipment, then you need to classify it. You need to have the characteristics for that. Once we have the classification of that, then only you would be able to onboard that information into the ERP. That's why. And then when we are creating an EBOM or FBOM or modifying an EBOM or FBOM, there is a huge dependency or vital dependency on the material master. So the plant maintenance and material master will always have to work hand in hand, and there must be seamless integration from material master to the plant master, plant maintenance to the material master, both of them. And what is the beauty of the solution that is absolutely unique to PiLog is that no manual loading, from the back end. And we have seen, we have heard, and you might have also seen that many a times once the project is finished, everybody prepares Excel spreadsheet loads, and then they try to load it using LSMW for SAP, or loading it into other Maximo or other systems. We don't have to. The governance solution need to have that capability. If we do not have that, we will not be able to establish the single version of truth. And no need to write the custom programs. It has to be seamless integration between the governance solution as well as the ERP solution. So end-to-end governance, from starting from the onboarding, loading, deduplication of it, enrichment of it, cross-linkage of it, and then improvement of any of the other things, extension of that, everything need to be seamless. And this is actually the beauty of the solution that we are bringing to the market, or that is what we are proposing to be utilized by the industries where there are greenfield projects or brownfield projects. Now we will quickly go through some of the screenshots to give the glimpses of the solution, such as if you have an SPIR register and upload, this is the entire SPDP that can be attached here. So everything is electronic, nothing is manual here. And at the end, each item of that SPIR would result into characteristic data, reference data, as well as the end equipment data, and then the descriptions of it, including the image, plant, location, position. All of this is captured from the ESPIR. And then in terms of the ESPIR management, it's not that you are just loading the data, it goes through the governance flow. It goes through a requester or a contractor who is loading it, EPC who is loading into it, and vendor is validating that, or vice versa. Vendor is loading his EPC is actually reviewing and approving it, and then the plant maintenance guys, they are reviewing it, approving it, and it goes through lot of steps during this entire onboarding process. So verification is important, and then the enriching, cataloging it, as well as approval is also important. So it goes through various stages, and once that is done, it actually gets transferred into SAP. And the screenshots that we are showing here is the integration with the SAP system. Once that is loaded into SAP, you can see that it's not a back-end load, it's not a manual entry, everything is done systematically, electronically, it is being done. And for an example, asset classification, if you are loading the asset data into the EAM system or into the ERP systems, and this is how the class characteristics and the descriptions gets generated out of the system, and this information goes and sits into the SAP or non-SAP systems or any ERP systems. And then this is a hierarchical view. You could see here that what exactly is that particular system. Under that, how many equipments are there, and that's the equipment description as well as the tag ID, and then that's the equipment BOM for that, the bill of materials for that, and then the for each of that bill of material, again we have the BOM attributes, and then there's the equipment classification of it, and then the classification properties. So all this data is acquired, enriched, harvested from the SPIR as well as the SPDP packages. And this is again another viewer of it. That's the equipment hierarchy. You will be able to create the maintenance task, task bombs, and task instructions. So this is how you can actually cultivate all the information and manage it via a ESPIR solution, which is part of the governance solution, so that you can load the data into the target systems going forward. And that sums up the entire ESPIR stuff. And then going forward, Mr. Ram would take us through the next topic, which is the service management as well as the fixed asset register.
Thanks a lot, Imad. And just to touch base on what are the points, some of the things which we had actually moved at a fast pace in the last session, right? Talking about specifically on the measuring point encounters. And there were some specifications also coming from some of the industry requirements and also some of the potential customers, right? So we again go back and see that what we meant, that why it is important today in the world to actually start working on the measuring points, the counters, and talking about the condition-based monitoring, right? And how does it enable the reduction of the breakdown? Because breakdown is something which none of the organizations will like to have, right? So they definitely would like to see that how I can optimize and maintain the assets on an ongoing basis rather than taking a downtime of the production, impacting their business objectives, the operational objectives, or in terms of their overall losses, right? So to overcome that, condition-based monitoring is the buzzword today in the maintenance era, and they talk about how can I enable the maintenance, and that we have talked about, saying that there are different types of condition-based monitoring, right? Whether it can be counter-based depending upon the cycles or the time of usage, right? That's what we talked about, an example of airline or a jet craft flying hours. Based on the manufacturer recommendation, OEM recommendation, they have to go for class A, class B, or class C kind of a maintenance, right? After a certain stipulated period of time of flying hours, which can be varying from 1,000 hours to 10,000 hours, and there will be different tasks associated with that, wherein whenever you do different class of maintenance on a particular jet engine. Similar way, if you're talking about a linear or a non-linear asset, which has a remote connectivity, wherein you access the asset or an equipment through GIS mode or through internet connectivity of the remote, based on the remoteness, that information also can be captured and analyzed. That we will see when we formulate the strategies for maintenance in session 4, right? How do we actually formulate the strategies? What strategies are applied when? And how do we enable it taking forward? So looking at this lookout, we have two set of, or a high level two set of condition-based monitoring or a counter-based monitoring when we are talking about. One typically talks about based on the usage. Second talks about based on the condition of the equipment or the associated components with the equipment. Like for instance, the brake pad, depending upon the thickness, we will typically talk about the maintenance has to be done, and this information is fed live from the real time, because depending upon the usage, how much the brake pad is getting worn out, this information is done and given back to our maintenance planning team as an input, and that is formulated from the system itself. How do we optimize it on an ongoing basis? So in order to look at from that perspective, it is very important for us that what we should measure, why we should measure, when to measure, where to measure, and how to measure. These are various questions which are typically fed as part of our analytical research, and also taking it forward in terms of how do we enable the equipments work on these questions, right? Basically, we are trying to ask these questions and trying to enable it in such a way that all these algorithms and the requirements of the market or of the industry are taken into the system, right? Through either artificial intelligence, through machine learning. You feed these inputs, and that actually automates your planning frequency, the planning schedules, and also your data acquisition system also. right? So how do I acquire the data when I acquire, and what is the importance of the data, right? Acquired from the field. So this is something which every maintenance guy keeps on asking, and we help them to address this question in an optimal way when we are actually working with them to optimize their maintenance strategies. Now, this is one of the examples which I just wanted to quote it from the last time is, see, looking at how the SAP interface, right? How the SAP interfaces with the third-party systems and your barcodes, let it be your process control systems like SCADA or your DCS or your PLCs, and also a lot of other internet-driven solutions, right? How do we actually integrate with SAP in order to formulate these processes and programs? So this is something which will enable also. This can be SAP or Oracle or any other CMMS system, best of breed, let it be Maximo or anything else. We will help them to integrate it, formulate a data models, and that will enable to take effective decisions. And this is the very foremost insights which any organization is looking on today to play for their maintenance optimization. Okay, having said that, let's move focused on our current today's agenda is looking at what is my service contract, how do I manage my service contract, what is the importance of service contract or release orders related with my asset life cycle, right? When you look at the asset life cycle overall, right, it's a whole gamut of stuff. Most of the things which you look at it is an organization today from a maintenance standpoint or an operational excellence standpoint is looking at how do I actually engage with my equipments today? How do I upkeep the performance? Should I do an in-source, outsource, or core source, depending upon how I actually can optimally maintain with the lowest cost, right? Because cost has been very imperative in terms of asset management. So in order to look out from the broad objectives of managing the assets, services become very pivotal, right? Because service management becomes very pivotal in terms of managing the assets effectively. Depending upon the SWOT analysis, what we do with in our in-house capability, and also looking at the pros and cons of having it acquired from the external agencies. So when you start doing that, you try to look upon what is my service requirement today from an asset lifecycle management. What is my category? How do I group the categories? What is the service type? What I am looking at? Does it help me to define the services effectively in terms of whether I have the right information set there? Does it have the right information categorization? Does it have the right information structure in terms of what kind of task I would like to what you call do on a particular equipment, depending upon different types of maintenance which is done, right from your preventive maintenance, predictive maintenance, or even going for the shutdown maintenance, which can happen at a different levels. That would be at a section level, plant level, or an organization wide level, right? So how do we manage it? How effectively we can define the activities? What can be the prima facie of getting it in-sourced or outsourced or even co-sourced? So those are the things which will come into play when we structure our data to enable the right service contracts and release orders for organizations so that there is no delay in the schedules. So that is what in the benchmark standards, if you look at it, service management helps you to manage the equipment within your predefined limits and objectives and ensure the performance is taken care of in terms of meeting their objectives of equipment, effectiveness, availability, etc., etc. So this is predominantly what we do, and we also help our customers to go ahead and talk about for the current requirements and the futuristic requirements, what should be the scalability of your operation in terms of managing your characteristics and characteristic values, which in turn will reflect in their ongoing sourcing and procurement processes also, which is tightly linked with your asset life cycle, right? So with this intent, let's move on and see some of the examples of spend by service category which we have seen for a large petrochemical industry, right? So wherein we are talking about how do the service spend typically structured today. This is prime important because spend analytics, till the time we don't do it effectively based on the right categorization, based on the right types, we will not be able to optimize our sourcing ability. Let it be in-source or outsource, we will not be able to do it. What is the essence of in-sources? In the sense like how much I should train my internal capability to typically meet the demand. Or if I want to go to outsource, that do I have the right people who can meet my standards, who can meet my expectations, keeping my costs low. So this is pivotal. This plays a pivotal role in terms of spend-based category management. And once you have identified the categories properly, you have segregated them, you have the right insights about your ongoing process or the future demand, you will be able to structure the spend analysis and take effective decisions. And this is very primitive and very important aspect for asset lifecycle performance management. So with this note, let's look at some of the specifics from the industry today. If I look at it, that some of the leading industry players with whom we are working upon, they define the scope saying that this is what I need in terms of my service directory standardization. They talk about my optimization of standards based on ISO 8000, let it be ISO 24745, or they talk about even the equipment standards, right? If you are talking about oil and gas, they will talk about 14224, or they will talk about ISO 55000 and 45000 for other industries. So when you blend all this and try to optimize the standards for the hierarchy, the cleansing, that definitely helps standardization not only of my service master, but also taking forward into the service management or the service contract management for asset lifecycle. So with this, if you look at the primitive scope for some of these customers, what we have been working with, we have predefined, or sometimes we have predefined deliverables, which are international standards, and sometimes we tailor-made it to meet the demand of the customer. But at the same time, we ensure that the value management, right, that is predominantly important, that on time we showcase that what is the value you are getting based on the deliverables and the outcome which we are trying to measure, right? In terms of like, okay, I will talk about designing the service master, and I will try to categorize it. I'll define how it can be interlinked with your other processes of supply chain. How do I give the analytical outlook for even managing your contracts, the service orders or the release orders, and how the categories are in turn looked upon from a spend management, right, on a real-time basis. You are not doing the analysis of spend, suppose once in a year. It is an ongoing basis to help you to take the corrective actions on an ongoing basis from a supply chain perspective also, not just the maintenance. Because if maintenance is not adhering to the standards or the requirement of the contract or the release orders, how do you manage it, right? So that is something which is very important. But at the same time, the services are complex, right? Services are not just the free text services of probably 200 characters, 300 characters. If you look at a plant shutdown and if everything is outsourced, including the materials, labor, and the tools associated with that, it has to be properly defined. It has to be structured, right? So that is where the model service specification comes into play, that for each activity, for each section, for each plant, or the operational equipments and assets associated with that, what should be my structure? How do I define it so that it is writing on the wall for even for the vendor and also for my internal stakeholders to understand what is the requirement and what is the expected outcome out of it. And when we are doing it, it is primitively very important that this from the ERP systems, right, gets integrated with multiple processes. Let it be supply chain, let it be vendor management, vendor rating, and also to do with your asset life cycle planning and execution activities, right? Because there are a lot of things which are associated with assets, even that you cannot take an asset out for maintenance just like that. You need to have a work clearance management. You should have a plant shutdown plan. There's a startup plan. There is a downtime plan. Everything is put in play, right? So these are all the things which are taken into consideration before we articulate what are the deliverables required for executing this kind of a program. And definitely, yes, people typically look at what is the outcome, right? What I am going to get the value out of it. First and foremost is definitely, yes, when you categorize the services, they define the hierarchies, you know what you're spending upon, what kind of right suppliers you have, how do you typically have the right suppliers sourced from the market, do you have preferred suppliers, and how do you manage your preferred suppliers, how do you enable them as business partners, what is your contract compliance from a SOX perspective or your international standards, whatever you adhere to in your industries, and how do I typically manage the reporting and the dashboards for decision making for the future. So all these things bundled with your program objectives, right, are being enabled through our services for enabling service management. And services are the key, and you will know that around 40 to 50% of the services, right, for asset perspective is directly linked to the cost. So how do I bring the right tools? How do you bring the right manpower? How do you optimize the performance so that there is a lower downtime? So keeping that in mind, we will take the questions at the end, but this is very important topic for an asset lifecycle management. And then the last topic for the day before we get on to some of the case studies is looking at your what you call fixed assets. What are the various fixed assets? When you look at the fixed asset, right, people keep on talking about how do I manage my fixed assets, right? There is a financial data part of it. There is an there is an operational data part of it. So we are typically looking at from a financial data part of it today as part of the discussion that how do I manage my fixed asset? How do I structure it from a hierarchy perspective? How do you position it from a location perspective? Because these are the designs which have been outlaid by the EPC vendors and so on and so forth. How do I actually group it? And the financial management of assets, right? When it is getting registered as a master data in SAP or in even Oracle, how do I typically apply the depreciation standards? What are the rules of the land? How do I take the benefits of my asset depreciation? How do I track my assets on an ongoing basis based on the performance as well as on the conditions, right? Which in turn can be linked with the asset lifecycle management in terms of looking at their replaceability, the performance, the endurance, right? So these are the things which are tagged with our asset lifecycle solution, which we promote in the market, saying that how the assets have to be maintained on an ongoing basis. So having said that, there is a process which we always follow for an asset management, right? Because we are talking about the assets coming usually from the capital projects, right? Wherein there is an investment, and based on the investment which is coming in, we also look upon the maintenance strategies which are applied to it so that we can maintain and manage the conditions, right? And monitor the conditions on a regular basis. There are certain standards which we typically look upon based on the WBA work breakdown structure. What are the requirements from a standards perspective, and how do we take it forward? So having said that, this is something which we are typically looking at. So how do we actually take it forward from an organization perspective of moving from capital projects, right? How do we build my asset management on an ongoing basis? How the maintenance structures have to be done? These are formally done as part of the EPC project as a parallel outcome project. That how do we run with it, and how do we capture the right information coming from the EPC and structure it for your ERP needs for the future for operations? So this is at a very hindsight which we are talking about, and this is a very important and critical subject for the industries today, right? And with that, I will quickly take you through some of the case studies in the interest of time. Like some of the things which we have done in the past is how do we actually manage the industry's requirement, right? The objectives. Some of the objectives they come and tell us most of the time, they say, hey, I want to reduce the maintenance cost. I have X number of equipments or assets, but I don't know the performance parameters. How do I improve my OEE, equipment availability, MTTR, MTBF? How do I reduce the maintenance cost? How can I reduce the inventory cost? So these are all the things which will come into play. And also they will talk about how do I typically use the automation techniques. And these automation techniques, we will see it in detail in the fourth session, that is next week, that how can we actually apply automation, and that automation which is data driven and data centric can improve the performance. So this is something which we look at from an objective standpoint, and this was one of the objective of one of the customers also even, right? And when we went and PiLog went with a rich repository of maintenance strategies aligning with ISO 14224 standard, because this is typically an SAP centric solution which they had for a brownfield, and they had typically maintenance objects associated with that in an oil and gas industry. And then they were also looking at how can
1 to 1.5 minute. We have 1 to 1.5 minute to close. Okay, thank you.
Sure. So before that, I would also like to talk about it, saying that they also looked upon that how can we typically bring in Kaizens in digital asset management. This is also one of the things which they were looking at. So what we did there is we had a phased approach for them, wherein we went ahead and talked about what is their maintenance maturity assessment today, right? That's what we have been discussing, that diagnostics is very important and critical when we start the program. And then refine their KPIs and KRAs looking at the international benchmarks and their current maturity models. And then we optimize their policies, procedures, and strategies on maintenance, and then slowly moved on to optimize their criticality standard, because if you look at the maintenance plans and frequencies, is always linked to a criticality of an equipment. How much effort and time I have to give for an equipment to collect the data, to manage the data effectively. So these are the things also which we brought into pit table. Doing this, what we have done is we have implemented a standard solution, because most of the asset lifecycle management solutions are data driven. If you don't have the right master data, you don't have the right controls on extracting the metadata from the real-time systems of the field, you'll not be able to take effective decisions. So this we have automated it, this we have got it embedded into their processes with the planning and execution system taking the feed from there, and that has actually lowered their maintenance cost year on year and also improved their inventory cost, because the maintenance is reducing. So the maintenance, once it is reducing, the demand is reducing. If the demand is reducing, we are able to optimize their min-max levels, reordering point, etc., etc. And this helped in even doing the effective demand management and forecasting, right? Which is very critical for us, that we cannot just talk about just risk management and just hold the inventory. How do we optimize it? How do we reduce the number of maintenance cycles? And these are all the things which have helped them to actually save a potential sum of $30 million per year. So with that hindsight, I just stop here, pause here, and we are open for taking questions or anything else. Mr. Imad, you can take it forward. Thank you.
Thank you, Mr. Ram. Fuad, would you please run the poll, please? And in the meantime, if you have any questions, don't hesitate to ask. Please shoot the questions. Panelists, have you seen any questions?
Yeah, Imad, we have one question that is related to the first topic, SPIR. So I'm just going to read it out. How can we optimize SPIRs on an ongoing basis? What's PiLog's lookout for it?
Ram, would you please answer that?
Yeah. So Imad, see ESPIRs, when we are looking at it, right? See, as Imad was talking about, it starts right from the day the inception of the plant, right? And there is a recommendation coming from the EPC vendors, and then you have a warranty period, the guarantee period, and then you have handover to the production also happening based on the essence of the maintenance life cycle or the asset life cycle. And during that process, there is a recommendation coming from your EPC vendors, which in turn impacts not only your inventory holding, but also the alternatives, because sometimes you might have seen that the OEMs doesn't give you the OPM numbers directly, right? They don't give you the information directly. So working with us, it helps us on an ongoing basis that we will help you to identify the components, okay, which is interchangeable, replaceable, or adoptable, right, for your operational excellence, which will in turn reduce the cost of your inventory. And that's what we help to do it. Basically talking about from EPC to OEM to OPMs, how you can standardize it with other components which can be easily procured from the market, which reduces your cost of inventory and your maintenance. Anything else, please, Imad or Vijay.
It was on the spot. Okay, next question, please.
We have another question from the audience. Okay. How does the FAR, fixed asset register solution of PiLog, complements with financial asset or operational asset framework embedded on ERP, in ERP?
Mr. Johan, you would like to take that? Johan Slidam?
Yes, please just repeat again, Qureshi, sorry.
How does FAR, fixed asset register solution on PiLog, complement with financial asset or operational asset framework embedded in ERP?
Yes, it's a good question. So the old school is where your engineering guys are working separate from the financial. So if we look at the life cycle of an asset, it starts in a CapEx world and it needs to end up in an OpEx world. We need to find out, and the reason why we integrate is that we track the costs. Because we have the master data, we can track the maintenance costs of the OPEX side as comparison to the actual CAPEX, your value that you spend to acquire that asset. So by doing an integration of the master data, we have the life cycle encapsulated from the CAPEX side right through to the OPEX side. Therefore, you can make better decisions about your asset.
Any more questions? Thank you, Johan.
We've got one more, Imaz. So it says, how can PiLog aid in taking right decisions in services management outsource, co-source, or in-source strategies?
Mr. Ram or Mr. Vijay, you would like to take that?
Sorry, I was speaking on mute. So see, if you look at the strategies from a service management perspective, right, the primitive of a maintenance function today, right, is how to bring my costs down and without compromising on quality. These are the two aspects which they always talk about from a maintenance perspective. And definitely, yes, the timelines, the schedules, everything has to be managed because they have to have the downtime and uptime as per the schedule, right, the planning of the service management. Now, when you're talking about outsourcing, insourcing, and co-sourcing, they always look at these three barometers based on the skill set availability, based on the tools availability, and also based on the ability to upkeep the systems for futuristic requirements on an ongoing basis. So having said that, our service categories, the service management, when you make the master data, we ensure that it has been built, the model service specifications are built, which will enable both co-source, in-source, and outsource functions, because we cover the whole gamut of the services which needs to be done on that particular piece of equipment or a plant or a section, right? So the decision lies with the customers based on their operational maturity, which we help them to assess the operational maturity and take a decision that what kind of services they should outsource, in-source, or co-source in the current scenario, and also talking about the outlay for the future. And that is the roadmap what we build for them.
Thank you.
Anything
There
further?
are two questions. Sorry, Tom, you would like to elaborate more?
Is that answer sufficient, or is there something else which is also looked upon from that question? That's what I want. That's it. Thank you.
I think the message is clear. So another one is which I'm answering now is that, is there a specific template for using ESPIR? Yes, absolutely, Mr. Mohammed. We have a specific template, and the same template can be actually shared when the EPC's contracts are getting finalized, so that they can circulate that internally with the vendors as well as the OEMs. That's the one question. And then the other question is yes, is task list preparation part of PM? Yes, absolutely. Task list preparation is part of PM, and you could have function location specific or generic task list. So, and how is it implemented? It's implemented during the data governance. Mr. Vijay, there is a lot of background noise from your side. So how is it implemented? It is implemented as part of the
PM and the EPC in the format.
Okay, are there any questions?
Ahmad, I can give a little more light onto this question which was asked last.
Okay, please go ahead.
See, when you are talking about the ESPIR template, we can also look into another aspect of when an EPC contract is being awarded to the vendor, especially when it is a large project. We can request him to interface his ERP system with the PiLog MDRM, wherein not only services, all materials and services which are procured by the EPC contractor using his ERP system can be seamlessly brought into the MDRM, and from there to the ERP system of the company. Thereby, you will have entire data starting from materials, drawings, as-built drawings, all the design, all the specifications, purchase specifications of all the material and the services which they avail. Thereby, you have a ready-built data available in your system, and this data can also be used to create the functional locations, fixed assets, and also the equipment master without looking into again these data, because it is coming directly from the EPC contractor's system, where he processed the design, he processed the procurement, and he did the installation. So entire chain of activities which EPC contractor did can be duplicated in SAP through MDRM for all the master data, and thereafter the drawings can also be brought into the document management system.
Elaborated explanation. Thank you. Are there any questions?
Imad, the last question from the audience is: services structuring and hierarchy management has been dynamic and organizations struggle to manage it. How PiLog will manage and help us?
Anybody who would like to take that? Vijay sir?
You are talking about ongoing process of service structuring. Yes, see, the service master solution can provide structured services data, not only for the new codes which are new services which are required, even for existing data can be structured, and an ongoing as an ongoing dynamic process, we can go on reviewing the services created, and also the requirement for all spend analysis. All these things can be done using the MDRM, and the PiLog team will be able to do that as an with interface to the SAP, and with the downloading of data from SAP on regular intervals and looking at the health of the system.
I hope that answers the question. Thank you, Vijay sir. Any other questions? If not, we were, already we have overshot this by 6-7 minutes. But thank you very much.